Now, the next topic which comes under capacitor is the formula of capacity of a parallel plate capacitor. As you know, capacitor is a device which stores charge. So, let us study the formula of capacitance of a parallel plate capacitor. So, parallel plate capacitor, it is having two conducting plates. In this, one is having the positive charge and the other side is having the negative charge. This is connected to earth and the distance between them is written as d. Now, using the Gauss theorem, we had found the expression for electric field inside the two oppositely charged plates having the surface charge density plus sigma and minus sigma. So, in that case, we had found the formula for E as electric field is equal to sigma upon epsilon naught. Sigma upon epsilon naught. Where the electric field E exists only inside the two oppositely charged plates. So I can write the formula E is equal to sigma upon epsilon naught. Now epsilon naught is taken here because there is no medium inside the plates of the capacitor and D is the distance between the plates. Now our formula for C, capacitance, is equal to Q upon V, where V is the potential difference between the plates of the capacitor. Now, how much is the potential difference between the plates of the capacitor? So, that is given by the formula V is equal to E into D. Now, this formula you have to remember that potential difference is given by electric field into distance between the plates. Now, in this case, it will be the distance between the plates and V is the potential difference. You must be remembering the formula for potential difference as V is equal to minus E dot dr, which we had derived. Now here, in case of plates of the capacitor, the potential difference will be written as E into D. Now here we substitute the value of E as sigma upon epsilon naught into D. This is the value of V. Now what is this sigma? Sigma we have studied. Sigma is equal to surface charge density or charge per unit area Q by A. So if we substitute this Q by A here, then we'll get V is equal to Q upon A epsilon naught into D. This is the potential difference. Now we require the formula for capacitance. Derive an expression for capacitance of a parallel plate capacitor. So we know our formula, standard formula, C is equal to Q upon V. So we substitute here the value of V. So it becomes C is equal to Q upon A epsilon naught into D. From this expression, I have substituted the value of V here. So now Q will get cancelled and our formula will be equal to, this will go in the numerator. So A epsilon naught upon D. This is the formula for capacitance of a parallel plate capacitor without any medium. Epsilon naught shows the permittivity of free space. So if we don't take any medium, then this is the formula for capacitance. Now you can see that capacitance depends upon the area of the plates. If I take the area of the plates bigger, if the plate area is, this is the area of the plate of parallel plate capacitor. So if the areas are bigger, naturally more charge will be stored. And the second thing is the distance inversely proportional to the distance between the plates. Capacitance is directly proportional to area, inversely proportional to the distance between the plates. Also it depends upon this epsilon naught value. If I take a medium, then in place of epsilon naught, our formula for the medium will be equal to A epsilon upon D. In case of a medium, this is called permittivity of the medium. Now, what is this epsilon? Epsilon is equal to K times epsilon naught. If you remember, K times epsilon naught. And what is the K? K is dielectric constant of the medium. So if I substitute here the value of epsilon here, in this case if I substitute the value of epsilon, then capacitance in medium is equal to K into A epsilon naught upon D. Because I substitute the value of epsilon as K here as K times epsilon naught. Epsilon is substituted as K times epsilon naught here. So K times A epsilon naught upon D, and this A epsilon naught upon D is nothing but C naught, where C naught is the capacitance without any medium. So this is the final conclusion, that what I have written finally, that capacitance with a medium, if I insert any medium here, the medium may be an electrolyte or it can be a dielectric medium. For example, mica or paper or electrolyte, some medium if I insert here, in this case a block, then that will cause an increase in the capacitance K times. So C with medium is K times C without medium. So capacity can be increased say 5 times, 10 times, 20 times depending upon the medium which is chosen. So if we choose a proper medium, we can store more amount of charge. So capacitance of a parallel plate capacitor, it depends upon first the area of the plates, second the distance between the plates, and the third is the medium between the plates.